For ease of communication, I'm going to number these charges off. And let's focus on point A first. So I have to imagine I have a positive test charge, like a proton, for example. Pretend I put a proton right at point A. What's the net force that it would feel? It would feel 4 different forces. The ones from 1 and 3 look like they'll cancel out though. They're both repulsive forces in the opposite directions, so they kind of cancel out. Charge 2 would probably push the proton away from it. At the same time, charge 4 would actually attract the proton towards it. So the answer for A should be away from charge 2 and towards charge 4. Yeah, that's pretty definitively the answer there. Okay, point B. So similarly, point B looks like it's right in between charges 2 and 3. And a proton placed at point B would repel from point charge 2. It would also repel from point charge 3, and they'll probably balance each other out as long as it's exactly in the middle. From point charge 1, a proton would feel a repulsive force. And then from point charge 4, it would feel an attractive force. And they'd be probably about the same strength as each other because they're about equal distance away. So a proton placed at point B wants to go down and to the right, but it also wants to go down and to the left. So it's going to the left and right components are sort of going to equal each other out. And the final result will be that the electric field will be just downwards. Yeah, it'll be downwards. Okay, and now point charge C. So this one's more complicated. I don't think anything cancels out here. So I'll analyze the forces from charges 3 and 4. Okay, so if I put a proton where C is, it'll want to go to the left because it wants to repel from charge 3, and it also wants to attract to charge 4. So it'll definitely want to go to the left really strongly. However, point charges 1 and 2 will actually repel the proton away from it a little bit. So there's going to be a slight downwards component as well. So it's got a strong leftwards component, and a small downwards component being repelled from charges 1 and 2. So it's going to be on a slight angle down and to the left. So I'll draw it like this. And those are the directions I would put for the electric fields at points A, B, and C. There was that simulation. You can try to set it up and see if the arrows they have in the simulation point in the similar directions as I have drawn here.